Hi friends, Mr. Ben here, and today for Science Explorers, I wanted to introduce you to Mae Jemison. Now, many of you probably have never heard of Mae Jemison, and here is a picture of her. But as you can tell from the picture, that she is known for being an astronaut, and not only that, she is known for being the first black astronaut in space. But it does not stop there, because this woman is very accomplished. Not only did she become an astronaut, but she also became a medical doctor as well as an engineer. Her past is very storied, and I hope that I can do it justice here in the short amount of time that I have. So she was born on October 17th in 1956 in Decatur, Alabama, to a school teacher and a maintenance supervisor. So as of today, she is 65 years old. She is still alive today. But as a young child, she was inspired by Lieutenant Uhura, who appeared on the original Star Trek. And that made her think about wanting to go into space. But in the meantime, she ended up going to Stanford University to get a Bachelor's of Science in Chemical Engineering and a Bachelor of Arts in African and African American Studies, where she then moved on to receive her doctorate in medicine from Cornell Medical School. Now, unfortunately, during her time as a student, she did face discrimination for being black, but that did not stop her from achieving just so very, very much. During her time as a medical student, she went abroad to help out in other countries, and once she became a practicing doctor, she interned and then eventually was able to go across seas again to work as a medical professional, and she did this for the Peace Corps. Now, what is advantageous is not only does she have all of this as her background, but she also spoke 4 languages. In addition to English, she spoke Russian, Swahili, and Japanese, making her a very valuable asset in the Peace Corps. But in 1983, Sally Ride became the first American female to go into space, and this pulled back on Mae's childhood, reminding her that she wanted to be the first black female in space. And so she applied to NASA, and after a few years, by 1989, she became the first black female in space aboard the ship Endeavour. This was actually consequently just after the Challenger explosion, so this is one of the first missions that went out to space after that happened. So, and not only that, her Star Trek inspiration came full circle, because she has appeared on newer versions in Star Trek Next Generation. She was actually able to appear on that show. And there are just so many other things to learn about. The most important of which is she now currently leads the 100-year Starship, what is it? The 100-year Starship project, which is an effort on humanity's part to make it to a star other than our sun within the next 100 years. So that's a really cool thing to be working on. And so, thinking about stars, thinking about space, I wanted to do a little experiment today that talks about, well, why do stars twinkle? Because, I mean, you shouldn't be looking at the sun directly, but if you get a chance to look at the sun, it doesn't twinkle, even though it's a star. Well, that has to do with all the atmospheric interference that stars have to travel through, not just through our atmosphere on Earth, but also through all the gas and dust between us and the millions and millions of miles and light years for some that the light has to travel through. So today I wanted to show you how you can see why it is that stars twinkle. And for this experiment, all you're going to need is a flashlight, a tub of water, and some tinfoil. Now, I've taken the liberty to poke some holes in my tinfoil already. It might be hard to see with all the reflection there, but I actually doubled it up. I folded it over because the tinfoil itself is kind of weak, so I needed to double it up so when I poked the holes through, it didn't make a huge hole. So if you're trying this at home, you're going to want to double it up, poke your holes through. Now, you're thinking to yourself, but Mr. Ben, you just said the atmosphere and gas and dust. This is water. That's not a gas. Well, just so happens that while gases are not liquids, they are considered to be fluids. And fluids have properties, and one of those properties is the ability to kind of, mess and bend and pull on light. And so, let's take a look. So I'm going to quickly shut off the light. I don't know how much that'll actually help out, but we'll see. So, now that I have my star field here, I can put my light through. And as you can see, we'll get up close, really close, I guess super duper close. You can see that they're not twinkling, all right? But now, if we shine a light, we put our star field behind, and this will act like our atmosphere. And now if I shine the light through, and I kind of jiggle the water, all right? You can see that now these stars that we've made are kind of twinkling, all right? And that's because as that fluid moves around, it bends and warps the light that passes through it and causes it to just kind of move around, and that is what we know to be the twinkling. Let's turn the lights back on. And not only can you do this as an experiment to see how lights twinkle, but I could also take this and I could create my own star field by placing, maybe I had an empty receptacle here. I could place a flashlight down inside. I could put this over the top, and I can place this like this. Now, I just made a random assortment of dots, but you can look at star constellations that are actually out in the nighttime sky, and you can create your own mini planetarium in your room by using this, this little trick. Well, thank you for joining me today, friends. I'd like to thank National Grid for sponsoring this program, and hopefully you'll learn more about our friend Mae Jemison. And until next time, friends,